This is page 3 of the Exponents and Logs review. We are solving equations with logs. This first problem is the natural log of x equals 0. One way that we can go about this is raise everything to start to the e-th power. I do that because e and natural logs are inverses. These disappear, and we are left with log of x equals e to the 0, which is just 1. So log of x equals 1. This is log base 10, since it doesn't have anything below it. So this is also saying, if we convert it to exponent form, 10 to the first power equals x. If it's 10 to the first power equals x, then x equals 10. In this second problem, the first thing I notice is that we have log base 3 here and log base 3 there. Now, what I could do is I could move that 2 up using the exponent rules and then have the division of logs allow me to write this as one logarithm. But I think there's an easier way, because log base 3 of 9 is saying 3 to what power equals 9. And that's just 2. 3 squared equals 9. So we've got a 2 here equals 2. We got subtracted 2 log base 3 of x plus 4 minus 2 equals 2. Add 2 to both sides, you have 2 log base 3 of x plus 4 equals 4. Divide everything in half, you have log base 3 of x plus 4 equals 2. Now we can convert this from log form to exponent form. So we have 3 is the base, the exponent's 2, equals what's inside of here is x plus 4. 3 squared is 9, equals x plus 4, so x equals 5. Problem number 3. Log of x quantity squared minus log of the quantity x squared. Now there's a big difference between these two. This minus log of x squared, here we can pull the 2 out, just like we did. I guess we didn't do it on this page. Just like we've done it in previous pages. Negative 2 log x equals 3, and we still have a log x quantity squared. Now this to me looks like a quadratic. I can subtract 3 from both sides, and I can say u equals log of x. From here, what I've got is u squared minus 2u, when I subtract 3 from both sides, minus 3 equals 0. This factors to u minus 3 times u plus 1 equals 0. So u equals 3, or u equals negative 1. Substituting it back in, I get log of x equals 3, or log of x equals negative 1. Now, negative numbers aren't in the domain of logarithms, meaning I can't put in a negative number for x, but you can get negative numbers out. They are in the range. This allows me to say, well, 10 to the third power equals x, or in other words, x equals 1,000, and 10 to the negative first power equals x, or x equals 1/10. These are the two possible solutions to this problem. The last problem, given that a is log base 8 of 225 and b is log base 2 of 15, I want to express a as a function of b. The first thing I do in these cases, and by these cases I mean cases where I have no idea what to do, is that I try and rewrite it in a way that makes a little bit more sense. So I can convert always from log form to exponent form, and it's always a good way to sort of get a better understanding of the problem. The base for the first one is 8, and it's to the power of a, equals 225. And the second one, the base is 2, and it's to the power of b equals 15. Now, I see I have a 2 here and an 8 here. Luckily, I can rewrite 8 with a 2, namely 2 cubed. So 2 cubed to the a equals, and 225, it might be better to think of that as 15 squared. But, you know what? I think I'll leave it as 225. In other words, I have 2 to the 3a equals 225. Now, the reason I decided to leave it as 225 rather than write it as 15 squared is because instead, I think I'm just going to square both sides with the b. There's no real reason to do it one way or the other, just depends on what you prefer. I end up with 2 to the 2b equals, well, 225. Since both of these are equal to 225, this tells me that 2 to the 3a equals 2 to the 2b. And since I got them both to be base 2 already, lucky enough for me, I can just say that, well, 3a must be the same as 2b. If I want to write one as a function of the other, I can just divide both sides by 3. I have that a equals 2/3 b. This has been the third page of the log review. I hope that you found it helpful.